Everybody, let us have a short overview about the topic of matter, elements, compounds, and mixtures. So later on, we will have a short activity related to those different components. No? But now we will start about the word mixtures. No? From the word mixing, what are we going to mix? When we talk about mixtures, this is also part of a classification of matter in which we were able to combine between solid and liquid substances, between liquid to liquid substances, or possible between liquid to gas substances. The word mixture means to say to combine, to mix them up together. Right? Now, can we cite basic examples that we normally do in our daily life activities about mixing? Derived from the word mixtures of different substances. Okay. By mixing hot water and coffee. Mixing cold water and fruit juice. Mixing between salt and water. By mixing between sugar and water. As I've said, mixture happens between solid to liquid, liquid to liquid, liquid to gas, in various forms. And it depends also what are the changes that we're looking for. Right? So how do mixtures differ from substances? And how can you classify matter between them? The word mixture, it is a matter that can vary in composition. What does that mean? Either it is a composition of solid, it is a composition of liquid, or it can be a composition of gas. So we have there the types of mixture. One, heterogeneous mixture. Everybody, you read the word. Heterogeneous mixture. Okay, what do you mean by hetero? Means to say many. We can see different or various components, uneven appearance.
It looks like densities.
Yes. Okay. So that's exactly when we join two substances, still the other one is clearly visible. For example, when you combine oil and water, since the density of water is higher compared to the density of an oil. So therefore, the density of water submerged, while the density of an oil, will float, or it could be clearly seen at the top of the water surface. Now, that's the common difference between heterogeneous and homogeneous mixture. So, a mixture in which the substance which is not evenly mixed, still the other component is visible according to shapes, according to color, according to sizes. So say for example, we can say this group as heterogeneous. Why? Because they not all, in this group, in this room are boys, but also with a combination of, okay, it's already mixed between girls and boys, right? So not all in this room, okay, a group of girls. Since it's clearly visible that we can also some boys in here, right? So again, heterogeneous, the word hetero means many, no? Several or various component present. Molecules are not mixed up in an even distribution, right? So other components are clearly still visible, right? So another point that we need to remember, the word homogeneous mixtures. Okay, what is homogeneous mixtures? Again, please read the word homogeneous mixture. Okay, so what is homogeneous mixture? What is the difference, okay, between homogeneous and heterogeneous mixture? So the word homo means only one. Even when you mix or you combine other components between liquid to liquid or liquid to solid component, still, no, it ended up with one color only. Although there were 2 or 3 substances, you even mixed them up already, but still it ended up with one appearance, or it ended up with even appearance. Okay? So homogeneous mixture, this is 2 or more substances are evenly mixed but not banded together. No? Now say for example, when you mix fruit juice, no? So for example, orange juice, no? Orange extract or powdered, okay? Orange juice. And then you mix them up with cold water. It ended up with one color only, in which this is the indicator, a homogeneous mixture. You guys understand? So, what will happen at the moment? So, it is not by layers already, unlike between water and oil, in which there is a layer of composition. But for homogeneous mixture, you apply different separation technique or mixtures, no, by mixing together, but still, no, it is visible that it ended up with only one appearance. Okay? So, this is for homogeneous mixture. Do you guys understand between homogeneous and heterogeneous mixture? Okay, continue. Next one, you have to remember the word dissolve. No? What is dissolution or dissolving? The word dissolve means to say when there are form of solutions between sugar and water, between different powdered ingredients and water, between salt and water, we evenly mix that one into different form of dissolution or by means of dissolving. Right? So, in what way? For example, between sugar and water. So, it ended up with what we call sugar solution. Okay? Because we dissolve them. Either maybe 80% of sugar, 20% of water. Okay? So, that's very saturated. Higher saturated solution of sugar solution. Either we have to make it concentrated, totally dissolved. 50% of sugar, 50% of water. Do you understand? That's concentrated solution. When we talk about diluted solution, no? We dissolve between 80% of water. No? Diluted means to say the solvent, the water is higher compared to the solute. So 80% of water, then 20% of sugar. So what will be the result? It's very clear. Now we cannot see even the single crystal on it because that will be totally dissolved due to the presence of the higher amount of water particles. Okay? Because water is greater compared to the presence of sugar as a solute. Okay? So what will happen then to the molecules? Okay? So I'll repeat, in this homogeneous, molecules are mixed up in an even distribution. Okay? Always remember the types of mixture. Homogeneous mixtures, heterogeneous mixtures. You understand, guys? Okay. So therefore, homogeneous mixture solutions are well mixed, appears to be a single substance. Mainly in a solution, you have to remember the word solute and solvent. What are the examples of solvent? Give me the example of solvent. Water. Solvent is only water because water is universal solvent that can be used for every living organism, living things. So this appears. What do you mean by the word solute in a solution? Solute means to say it is a substance being dissolved, while solvent, the substance in which the solute is being dissolved. So solute can stand alone as a solution. When can we say that it is a clear and possible solution? If there is always a pair between solvent and solute. So it means to say that water is necessary in a certain solution. Okay? What are the examples of solutes? Okay, sugar, different ingredients, salt, okay, coffee powder, powdered milk, okay, monosodium glutamate, different powdered substances that we bought in our grocery shopping, for our kitchen needs, right? So those are the example of solute. Because solute will be dissolved by the help of water or liquid component. Water is considered a universal solvent. Always remember this. Water is not a solute, either cold water, tap water, hot water. Dirty water or clean water, they are all solvent. It's all about water. H2O is universal solvent. Okay? However, solute, it comes in two different substances. Liquid substances, solid substances, gaseous substances. So solute is secondary, while solvent is our primary component in a solution. Always remember that. So particles do not scatter light. Usually coffee, lemonade, Kool-Aid, and all other special component. Now, a mixture is a matter that can vary in composition. We have, again, I'll repeat, in mixture, two important components or composition. One, homogeneous mixture. Two, heterogeneous mixture. Right? So mixtures are combinations of two or more substances that are physically blended together. The amounts of the substances can vary in different parts of a mixture and from mixture to mixture. So as you can see, the difference between the two, right? It's very easy to simplify or even classify between two compositions. Homogeneous and heterogeneous mixtures. Right? So, there's also a word, what we call, in homogeneous mixtures, okay, under that there is colloids. What do you mean by the word colloids or colloidal particles? Yeah, colloids, okay, it is a kind of viscosity. It's still a liquid that almost hardened or almost transformed into solidified substance. So colloid substance, a mixture of tiny particles that are bigger than those in a solution, but smaller than in a suspension. Okay? Colloids do not settle out over time. For example, scattering of light. So, what are the examples of colloidal substances? 1. Mayonnaise, milk, gelatin, whipped cream. Okay? Those are the examples of colloid or colloidal substances. Under what? Under homogeneous mixtures. Remember also, under heterogeneous mixture, you have to remember the word suspensions. Okay? Suspensions. It is a mixture in which particles are dispersed in a liquid or a gas and will eventually settle out. Okay? That is what we call suspension. No? Suspended particles. Okay? I'll repeat, it is a heterogeneous mixture, no? Which particles are dispersed in a liquid or gas and will eventually settle out. So particles can scatter light, can be also filtered out using filter paper or filtered screen. Like for example, snow globe, sand in a bucket of water, muddy water, Italian salad dressing, or when we made noodles. Right? So that's literally how we were able to make with this kind of thing or to determine, okay, what suspension is. Next one is, okay, various particles. Okay, how those things are being made, no? As you can see, because the substances in heterogeneous mixtures are not evenly mixed. Two samples of the same mixtures can have different amounts of the substances. So for example, homogeneous mixture is type of mixture in which the individual substances are evenly mixed together. In homogeneous mixture, remember, the particles of individual substances are so small and well mixed that they are not visible even with most high-powered microscope. So therefore, to dissolve means to form solutions by mixing evenly. For example, our solute, okay, we have sugar solutions. Okay, how these sugar solutions are made? We combine or we mix together between sugar plus water. Sugar is a solute and water is a solvent. It depends on how many percent you're going to use. 50-50, 80-20, no? Or it could be 40-60, depends. Right? So that's how the bonding of molecules between these sugar solutions are being made. So homogeneous mixture is also known as a solution. Okay? So we have diluted solutions, concentrated solutions, and saturated solutions. Okay? When we talk about diluted solutions, solute is less, then solvent is high. When we talk about concentrated solution, okay, they are equal. There is a state of equilibrium. Solvent is 50%, solute is 50%. When we talk about saturated solution, means to say solute is high, but solvent is low. That's the way how to understand the indicator between saturated, diluted, and concentrated solutions. You guys understand? Okay, continue. So how do mixtures differ from substances? Mixtures are combinations of two or more substances that are physically blended together. The amounts of the substances can vary in different parts of a mixture and from mixture to mixture. So, compounds versus the solutions, the composition in which compound does not vary. Therefore, chemical formula can be used to describe each compound component. So, because of this, the composition in which the mixture can vary with a chemical formula cannot be used to describe its mixture. Right? So, therefore, to end up with these two important components of mixture, by the word dissolving,